many of you have experience with SQL Server or databases in general. And you might be familiar with SQL, Structured Query Language. Now, when interacting with database servers and doing SQL queries, you would run a query, get back records that have fields, and then you might search and sort these fields. Now, by analogy in PowerShell, there's several commands that are, by analogy, structured to follow that model of executing commands to do something like a query, searching a table and getting back records with fields, but instead of calling these things records, we call them objects, and instead of talking about the fields of the records, we talk about the properties of the objects. So let's look at some of these analogies. Again, many of you come from a SQL Server background or at least have some prior experience with this. And hopefully this will make it a bit more clear because these analogies with databases, tables, records, and fields, those are actually more useful analogies, and it helps us to overcome our old text-oriented habits. So again, if you come from a text-oriented command shell background, thinking of like the old CMD shell in Windows or maybe Bash on Linux, it's really, really hard to kind of forget or change these habits when we think in terms of a command outputting text, and then the text is piped into another command, then we manipulate and search that text. And especially this whole idea of how you can have objects that you can't see with your eyes and how they have these hidden properties and methods, and we have to take these extra steps to actually see those properties and methods. So, in the middle, we see a command get service. The output of that command is a stream of 100 or plus service objects. A service object represents a service on the machine. Now, those service objects have lots of properties, and I'm exporting those objects to export CSV. Now, in this case, it's going to create a text file on the hard drive named services.csv. And this is a good old-fashioned, comma delimited text file, right? There's no place like home, so to speak, right? Finally, we get away from all these weird objects that PowerShell is creating, and instead I have a nice, normal, well-behaved, comma delimited text file on the hard drive. And it is a nice, normal text file. You can use traditional tools like find string, sed, grep, and awk, or just double-click the file. In most cases, when you double-click a CSV file, it's going to open up in your spreadsheet application like Microsoft Excel on your computer. Notice on the next line, it says $data equals import CSV. And on that line, we're reading the services.csv file. We're reading that comma delimited text file, and the output of that command is going into the $data variable. That variable, by the way, that's called an array. Now, here's the critical question. We've exported a bunch of service objects to a comma delimited text file. If we have, let's say, 120 services on the machine, there will be 120 lines in that text file. Each line represents a service, or each line represents an object that represents a service. And each column in that comma delimited text file stores a different property of those service objects. Or again, by analogy with databases and SQL, we can think of that CSV file on the drive as like a table. Each of the lines is a record, and each of the columns is a field. Now, on the next line of the slide, it says import CSV, and we're importing from that services.csv text file. If that command were, let's say, the type command, or the cat command on Bash on Linux, we would be reading that file as a text file, and we would manipulate that data as text. So again, you might use tools like find string or sed, grep, and awk, that sort of thing. But that's not what's going on here. Import CSV reads the text file and creates objects out of the data from the text file. And what kind of objects does it create? It creates service objects. It knows how to, so to speak, recreate or resurrect those service objects out of that text file on the hard drive to create regular PowerShell objects in memory. And where are those PowerShell objects? They're in the $data array. So the question is, what's inside $data? Is it a bunch of comma delimited text? No, it is not. Because import CSV, yes, it's reading a text file, but the output of that command, what it creates, are service objects with properties. Or again, by analogy with databases, what it outputs are records with fields. Now, the good thing about common delimited text files, the structure is very simple. You can use tools like find strings, seggrep, and awk, open it up in a spreadsheet, or you could import it into, let's say, another database. Almost everything can import or read common delimited text files. But remember, all this is object-oriented. And we can run into a problem where a simple CSV file just doesn't cut it. So by analogy, in high school biology, maybe you were given a frog to dissect. We think of a frog as one object, but a frog is made of organs. Those are objects. An organ is made of cells. Each cell is an object. A cell is made of proteins, which are made of atoms, and so on. And the idea is that you can have one big object, the frog, composed of smaller objects, the organs, composed of even smaller objects, the cells, and so on. Or going the other direction, inside out. You can have objects inside of objects inside of objects. That means objects can be nested inside of each other. Another way of saying this is that you could have an object, let's say, that represents a user account in Active Directory, and one of the properties of that user account object contains more objects. And those objects have their own properties. Now, once we start nesting objects inside of objects inside of objects and so on, well, those nice, familiar, common delimited text files, they just don't cut it anymore. We need to save our data in a format that can preserve that hierarchical nesting of the objects inside of objects inside of objects. In other words, we have to export our data either to an XML file or a JSON file. So as you can see at the bottom of the slide, we could run that same command get service, but then pipe it into export CLI XML. And now objects with all of their properties, even nested, hierarchically nested properties, could be saved to an XML file. And then we could read from that using import CLI XML. So with XML, you could have a node that has attributes and child nodes. And those child nodes can have attributes in their own, like grandchild nodes, and so on. XML sometimes is a little bit heavy-handed. So over the last 5 years, another format has become very popular, especially for web services, and that's JavaScript Object Notation, JSON. And we have commandlets at the bottom for converting objects to and from JSON format, and then we could save that as a JSON text file. Or if you're interacting with a web service, we could take an object in PowerShell, render it or convert it to JSON, send it over the internet over an HTTPS connection to a server, which then could read and parse and use that JSON. This is such an important topic that there's a separate lab for this, because as you're writing your PowerShell scripts, you want to save your progress along the way. And when you want to share your progress and share your work with other people, well, you have to give them data in a form that they can use and understand. So in your manual then, please turn to page 94. In page 94, we're going to get some hands-on experience. Hopefully everybody's been following along with the commands so far with the commands and the slides on their own computer. But in this case, let's do an official lab on our own. So in this lab, you're going to get some practice taking objects in memory that you can't see, converting them into different file formats on the drive, and then also reading or importing from those file formats. As you're working on the lab, you might wonder, so which format should I use? When I'm saving data, should I save it as a comma-separated values file, a CSV file, as an XML file, or as a JSON file? Well, if the data that you're exporting is very simple, what's called flat data, just simple strings, simple numbers, then save it to a CSV file, especially if you're going to share it with other people. Now someone else can double-click the file and open up an Excel spreadsheet. On the other hand, if the data is more complex with nested properties, then save it to an XML file instead. The exception is if you're talking to a web service or any other application that prefers JSON formatted data, and that's becoming more and more common with web services. So in this case, you would save the data to a JSON file or directly pipe that JSON data into the web service. How could PowerShell talk to a web service directly? How could you pipe JSON formatted data to a remote web server? Well, you have a commandlet called invoke web request. Invoke web request. And that's the PowerShell version of wget or curl. So in that last lab, we got some experience saving objects in memory that you can't see with your eyes to text files that you can see with your eyes and you can manipulate as nice normal text files. And I know I often see, like when I'm teaching the course to a physical audience, and you can almost see like this wave of relief, right? The sense of, there's no place like home, all these weird objects in memory. Now we can save it to a file, and now it feels like you're getting somewhere. You're back on familiar ground. But there's more ways that hopefully this is familiar ground. Because if you have some experience with SQL Server and the SQL query language, then you might be familiar with how you could query a database to extract records from a table, including all the fields of those records or some of the fields of the records. And there's PowerShell commandlets that are modeled on this. So take a look at page 96. We have a commandlet called select object, and this is very similar to the select keyword in SQL queries. So for example, I'm going to switch back to my virtual machine to show these commands, but these are the exact same commands that are in the slide. So let's imagine that I do get process, and then I give the name of a specific process, like how about PowerShell ISE? When I hit enter, PowerShell displays a small number of the properties. But we know from earlier that if I were to pipe that command into getMember, we know that process objects have lots of properties and also a good number of methods. So why is it that when I run get process and then the name of one process, right? Why is it that PowerShell is only showing me a very small number of the properties? Well, this is kind of like PowerShell and Microsoft acting as a babysitter, almost kind of like holding our hand. Microsoft is concerned that if all of the properties were displayed to you, that you would be overwhelmed and intimidated. That might reduce your likelihood of using PowerShell in the future. So how could I tell PowerShell, go ahead, I can take it, show me everything? So I can pipe it into select object dash property star. Now, select object, by the way, has an alias. It's just select. And by the way, the dash property parameter, that's what's called the default parameter. And in this case, if you want to pass in the argument, the single star, into the default parameter, it'll go there by default. I'm pointing this out because this is a command you're likely to run over and over again, many, many times in your PowerShell career. So what's going on is, getProcess outputs an object that has many, many properties, and I do want to see them all. So I pipe it into select star, and PowerShell says, okay, here they are. Here's all the properties. On the left-hand side, you see the name of the property, like the ID property, or the VM property, that's for virtual memory. And on the right-hand side is the data inside that property. So in this case, I have a PID number, process ID number of 928, and I can see that this process has this number of bytes of virtual memory. So there's probably like 54 megabytes, if my commas are correct. But what if the only properties I care about are the name, ID, and VM properties? What if those are the only three properties that I want? Well, just like in an SQL query, instead of doing select star from a table, I could do select and then the names of just the properties that I want. For example, I want the name, ID, and virtual memory properties, and nothing else. And notice that all the other properties, or rather all the other fields of that record, are simply discarded. The output of the select command is a new object, but it only has the properties that you want. Now, if you pipe it into select star, well, then you get more or less an identical object with all of its original properties, but at least you can see all those properties inside your command shell. But if you pipe it in like I did here, select name, comma, ID, comma, VM, Well, then all the other properties that I did not select are simply discarded. I get now a much smaller, simpler object with only these 3 properties. And by the way, if I were to run that same command, but instead of doing one object as the output, what if I output objects that represent all of the processes on my machine? I could do get process, select, and I could choose the names of the properties, and I can choose the order in which those properties are displayed. For example, these are the same 3 properties, but now in a different order. And instead of showing these 3 properties or these 3 fields of one process object, I'm going to show it for all of them. So notice that the output is automatically converted to a table for you to make it easier to consume it with your eyes inside of a command shell. It gets better. What if I go back to that prior command? This is the one that, there we go, outputs one object that represents PowerShell ISE. I'm going to pipe it into select star. It gives me a list of all the properties, the name of the property on the left, the data inside that property on the right. And if I scroll down just a little bit further, notice that one of my properties is named modules. And strangely, that data inside that property is not just one object, but many objects with their own properties and methods. Notice that the data here starts with an opening squirrely brace and then ends with ... squirrely brace. I would like to extract just the objects from the modules property. Now again, this is kind of like high school dissection when you were given a frog. So the teacher gave you some frozen frog and they said, okay, dissect that frog and take out these 3 organs. Well, in this case, I want to dissect that process object and I want to extract just the objects in the modules property. Now for this is a very handy trick. This is something you'll do likely a lot in the future. I'm piping that one process object into select, but now I'm using the expand property parameter followed by the name of a property. Remember that the modules property contains more objects. And there we go. There are those objects extracted from that property. Now these are module objects. Module objects represent the modules, typically DLLs, that you find loaded inside of a process. Now, these are more objects. They have their own properties and methods. And as you can see on the right-hand side, one of those properties is named file name. That is the full path to the module on the drive. But if you look to the right, notice that the data ends with ... on each of these lines. That's PowerShell truncating or slicing off the data for display on the screen, but the data is still there. It's just that it's not being displayed. So I'm going to run that same command again, because again, I'm now doing a bit of dissection. It's like the high school teacher saying, okay, take out the liver, and from the liver, extract just one cell. So in this case, I pipe that into select again, and this time I choose just the one property I want, the file name property. And there we go. I've now extracted the full path to all the modules loaded in that one process. Now, it's very often on this slide and these demos where things start to come together. You say, so yes, it's not text, it's objects that have properties and methods. And some of these properties are more objects with their own properties. And some of those properties contain more even littler objects with their own little properties. And we can extract these things. So you take the frog and you, high school biology, and take out the liver and you take out the cell and then you take out the DNA and then you take one of the atoms out of a DNA molecule. And that's kind of what we're doing here. So we are like dissecting the objects that are created. We're unpacking them. Or another way of saying all this is that, well, if you have database experience, then you know how a table could have a field that refers to a whole nother record in another table. And so you can do things like inner join and outer join, right, to extract just the stuff that you're looking for. But we're not doing this actually with SQL Server and tables and records and SQL. It's all being done in PowerShell. All right, so if you come from a text-oriented background, there's just very, very strong habits that you've acquired over the years where you think in terms of, here's a command that outputs text. Now I need to use a tool like FindString or grep, and I need to slice out of that visible text that I can see with my eyes a portion of that text. And from that text, you might need to use fine string or grep again to select an even smaller portion of that text. But it's still just regular old text. What you see is what is there. It's not like there's anything hidden. But on the other hand, when we start thinking about objects in memory with PowerShell, an object could be fairly complex with lots of properties, and some of these properties can contain objects with their own properties and so on. So now we have to do a bit of dissection, and again, if you have some database experience and you know about how you can have things like inner join and outer join, where you can link different tables together and whatnot, well, one way to think about it is a record in one table might refer to another table of all the little objects inside of the first record. Now again, if you don't have SQL or SQL Server experience, then those analogies might not be useful for you, but that's okay. Maybe you dissected frogs in high school, and hopefully that's a better analogy. All right, now here's a nice little trick, and this makes it even more like doing an SQL query. So here's that command again. And just to make sure we all know what's going on here, I run get process. I'm not going to output objects representing all of my processes, but only one, the PowerShell process. I pipe that into select expand property modules, because that PowerShell object has a modules property, and inside that property are a bunch of little objects that represent all the modules, all the DLLs. And so I pipe all those little module objects into select again. Those little module objects have lots of properties and methods, but the only property I care about is the file name property. So again, here inside the command shell, when I run the command, then we can see the full paths to all the DLLs, all the modules inside that one process. But notice that when I scroll down a little bit, I still see like ... at the end here. Now the data is there, it's just that it's not being displayed on the screen. What I need is something like a little query window, just like you have on Microsoft Access or Microsoft SQL Server or other database products, so I can display it in a graphical window. So I've hit up arrow on my keyboard, and I'm now going to add to the end of my command out grid view. So I'm piping those same strings, in this case the paths to the DLLs on the hard drive, but I'm piping them to out grid view, which pops up a graphical app, just like you would have in SQL Server or Microsoft Access, showing that one property. And now we can scroll down, grab this column header, I drag it off to the right-hand side, we can see that all the data is there, nothing's been truncated or replaced with ... And notice the filtering that I can do. At the very top, I could type in, for example, WIN, and now it only shows the lines that has WIN somewhere inside of it. And if I pull down Add Criteria, I can check the box next to one of the fields or properties, and then now I could do some queries like contains or does not contain, or is greater than, or less than, or is empty. Might look at this and say, well, big deal. I could just do that with a text file. But now, watch this. I go back, and I'm still going to pipe it through out grid view, but in this case, I'm going to pipe the whole module objects themselves, not just one property, but the whole objects. And now when I pipe it into grid view, notice there's more properties. So in this case, I still see the file name property, but I have the other properties as well. So when I click on Add Criteria, I can check the boxes for the properties that I want to filter and sort on. And for example, where the size property, let's say starts with the number 4, and the module contains or does not contain some attribute, and so on. And I can do some filtering here. Now, by analogy, just to simplify, so I don't have to scroll left and right so much, so you can see it a little bit easier. Now, what if I just run get process, I pipe it into out grid view again. Now, process objects have lots of properties, but here's another trick. I add the pass-through switch to out grid view. And now watch what happens. Get process outputs lots of objects with lots of properties, and we can see lots of the properties here. But because I use the pass-through switch, watch what I can do. I can highlight by holding down the Control or the Shift keys on my keyboard, I can highlight multiple objects, and notice in the bottom right-hand corner when I click on the OK button, it's only the highlighted records, only the highlighted objects that get passed through to the next command. So for example, what if I wanted to export that data to a CSV file? Well, in that sense, the output of get process is being piped into a graphical app where I can sort and filter and select just the objects that I want. And when I click on OK, those objects now are piped into export CSV and saved to a CSV file. Now, how about this for like reading comprehension, so to speak? I want to see all of the properties of these processes. So there's something right here. There's a command that I need to put right here to tell PowerShell, hey, don't hold my hand like a babysitter. Show me all of the properties. Show me everything. And what command would I put right there to tell PowerShell to output all of the properties? Ah, yes, that is correct. Select star. This is something you're going to do frequently in PowerShell. You'll run a command and pipe it through select star. Now when I do this, watch what happens. Now, all of the properties appear as column headers in OutGrid view. Not just the ones that PowerShell has selected to display for me, like a babysitter, but no, all of the properties. So when I grab this slider bar, I can scroll it off to the right-hand side. I see all of the properties and all of the data. And remember, I can type in and filter keyword at the top. When I click on Add Criteria, notice I've got a long list of all of the properties, or again, on analogy with SQL, all of the fields of the records. I see a list of all the fields, and now, for example, I could check the one or more boxes here, click on Add, and then now I could use that field as a filter. I go through and I might, for example, now hold down the Shift key and highlight, let's say, a half dozen objects in a row, and when I click on OK, it's only the highlighted objects that get passed through to the next command. It was only the ones that I highlighted. And because I selected star, I selected all of the properties, PowerShell displays to me the full names of the properties on the left and the data inside those properties on the right. But notice how far we've gone beyond like traditional text-oriented command shell scripting, where you output, let's say, some comma or tab delimited text, and then you try to slice and dice and grep and cut and sort and pad and unpad and all that stuff. In a sense, an object is like pre-parsed for you, is packaged for you, in the same way that you might have, linked tables in SQL Server, and all the data is already parsed for you into records and fields, and now it's just a matter of doing the right kind of query to get what you want. Can you use this to find DLLs signed by Microsoft and those that are not signed? Yes, you can. There's a commandlet called get authenticode signature. And for example, you could query a process on a local or remote machine, get the full paths to all the DLLs loaded into that process, and pipe each of those module or DLL objects into get authenticode signature, and then that'll output another object with digital signature information about the DLL. In fact, we're going to do something kind of like that on day 5. Now, how about analogy with commands like head and tail? If you're familiar with these commands on Bash on Linux, well, what's kind of like the PowerShell equivalent? As you can see at the bottom here, you run get service that outputs objects, not text, but I can pipe those service objects into select -first 5. So that's kind of like the head command in Bash. Or how about I run get hotfix? I pipe it into the alias select. Remember, select is an alias for select object, but then I use -last3, so that's similar to the tail command. Now, by analogy, what's the PowerShell version of cat? Or for the old DOS prompt, what's the equivalent of the type command, type? It's get content. So get content can read users.txt, a text file. Each line from the text file is emitted separately as a string object. And notice that the select command has a unique switch. So let's imagine that you have a list of usernames, And the usernames are like, let's say, Tom, 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 Mary, Jennifer, 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 Susan, Susan, Rachel, Rachel, Rachel. Notice that there's lots of repetition. So if you want to suppress the duplicates and only output the unique items, well, then you could get the contents of the file, pipe it into select-unique, and all the duplicates, all the redundant objects would be suppressed. So even though the name Mary might appear 5 times inside the file, it only outputs that string, Mary. It only outputs it once. Is there an equivalent for tail-f for following? Yes. Check out the help for get content and, for example, the wait switch. Now, it's not as efficient as tail-f. With tail-f, if you are following, let's say, a text file like on a Linux box, if you were to append data to the end of the file, well, tail-f will more or less instantaneously show you the new data appended to the end of the file. It's not as fast in PowerShell. PowerShell is going through the .NET framework, which is monitoring the file on our behalf, so there is a few seconds delay, but it is roughly the same idea. There is a command, get process, that'll output objects for all of my processes. I pipe them into select star, which tells PowerShell, hey, don't try to hold my hand like a babysitter. Show me all the properties. Even if this is going to produce 100 pages of output, I still want to see all those hundreds of pages. But then where are those objects going? In this case, to outgrid view. And then with the pass-through switch, you select or highlight the objects that you want. When you click on OK, only the highlighted objects get passed through to the next command. So for example, the next command might be something like pipe, and then how about export CLI XML? Like if I wanted to save that to an XML file. In a sense, it's kind of like gray matter grep, right? It's like we're piping the objects through the human brain, and then you choose which objects you want to grep or select, and then we're saving the data by exporting it to an XML file. The redirection symbol, what is this? For example, let's say that I have some text. I can display it on the screen. I can also pipe that to out file and give the path to some kind of output file like this, and that works. And this also works. The greater than or file redirection symbol. However, in PowerShell, that redirection symbol is just an alias for out file. So the greater than or file redirection symbol, that's an alias for out file. And by the way, you might wonder, does this command work? How about something like, for example, the PowerShell version of grep is called selectString, and can you read in a file the less than symbol? Actually, no. The less than symbol, that file redirection where you are reading from a file, actually that symbol is not implemented in PowerShell. So you can pipe the output of a command to a file, but you can't read in a file this way. If you wanted to read in a file and then pipe it into selectString, it would be something like this. That's how it would be done in PowerShell. So for the Linux people out there, or if you're familiar with the grep tool, G-R-E-P, then selectString is the PowerShell version of grep. For example, in PowerShell, you do have, I'm only guessing here what you mean by 1 for 1. Now in PowerShell, you can do star greater than, and that's for redirecting all of the output streams of the command. We don't talk about output strings, by the way, until day 5, because just be aware that a PowerShell command has multiple streams of objects coming out from it. There's a so-called success or normal output stream. There's also the error stream. There's also, for example, the information stream and the verbose stream, and there's actually about, let's see, 5 or 6 of these streams actually in the latest version of PowerShell. And if you do star greater than, that's a way of telling PowerShell, take all of the output streams, and for example, I could combine them all together, and let's say combine them into the normal output stream, or redirect them to a file. That's not in today's manual though, that's coming up later on this week. And again, this is coming up later in the week, but just be aware that, for example, when I pipe the output of get process, by default, it's only the what's called normal or success output stream. This is a stream of objects, not text, which is then piped into the next command, which might be, let's say, export CLI XML. But there are other output streams as well. And now we get to one of the most important slides in today's manual, because this is a command that you're going to use in virtually every function or script you write for the rest of your life. In an SQL query, you can filter the output with the where keyword, with the so-called where clause. This is probably better demonstrated than talked about. Don't worry, I'm just going to run the commands that you can see in the slide as well. So if I run get service, that'll output all of the services on my machine. But what if I'm only interested in the services that are not running? In this case, I run get service and I pipe it into where object. Where object, by the way, has an alias of just where. When you do this, you'll create a test inside squirrely braces where each object is tested separately, and only if the object survives or passes the test does that object make it to the next command. So here's how it works. Get service might output, let's say, 200 service objects. Each service object, one at a time, goes into $_. Think of that as like a catcher's mitt of a variable. So that underscore character, it's like a catcher's mitt which is being held, with the face up to catch something. And what are we catching? We're catching service objects that are being piped in. Now each service object, one at a time, is caught by this variable $_. Service objects have a status property. Now the status of a service can either be running, stopped, or paused. And now I'm performing a test. Is the status property of that first service object not equal to this string running? So -NE for not equal, -EQ for equal, -LT for less than. In the back of your manual, you have an appendix with a list of all these different comparison operators. So notice what's in the output. The output of this command is not all of the service objects on my machine, but only the service objects where the status property is not equal to running. In other words, the status is either stopped or paused. Now, on the other hand, I'll run that same query but make a modification. Instead of doing -NE for not equal, I -EQ for equal. And in this case, notice the status column on the far left-hand side. Now it only outputs service objects where the status property of that service is running. Inside the squirrely braces, you have to have a test that outputs either true or false. Like, for example, less than, greater than, equal, not equal, and so on. And if the test outputs true, the object being tested survives and is passed down the pipeline, or in this case, displayed on the screen. But if the test resolves or outputs false, well then that object is simply discarded. So very, very often in PowerShell, you'll execute a command, but you're not interested in all of the output, only some of it. For example, you don't want all the files on the hard drive, you only want the files larger than 1 gig. Or you don't want all the users in Active Directory, but only the disabled user accounts. Here's another example. Get command will output objects representing all the commands that you can run in PowerShell. Each command object has a name property. It's the name of the command. And in this case, I'm using the like operator to use simple wildcards for my pattern matching. So I'm looking for all the commands where the name of the command is like *item*, where those letters ITEM are somewhere in the name of the command. The like operator, right here, that's for simple wildcards like asterisk and question mark. Whereas the match operator, on the other hand, that's for regular expression patterns. So that weird looking text here inside the double quotes, we have the #secure period. That's actually a regular expression pattern. Because of time constraints, we can't really spend any time talking about regex patterns, but just do a search on the internet for regular expressions tutorial, and you'll find lots of tutorials on the internet. Again, inside the squirrely braces, we just need something that outputs true or false. Normally, we're performing some kind of comparison, like not equal, like, match, less than, something like this. But sometimes the objects that you pipe in have a property, and that property only contains true or false. For example, if you run get local user on a machine that's not a domain controller, that outputs local user account objects. Well, user account objects have an enabled property. If the account is enabled, the enabled property is set to true. If the account is disabled, well, then the enabled property is set to false. So in this case, what's being outputted by this whole command at the bottom is only local user accounts that are currently enabled. The disabled local user accounts are ignored, or rather, those objects are suppressed in the output. So very, very often you're going to run a command in PowerShell. It produces many objects as the output, but you're only interested in some of those objects. Like for example, if you're searching a Windows event log, maybe you're only interested in the failure events, not the successful events, or only the events related to the users Bob or Alice, and not for any other username. So this is one of the most important slides in the manual today. Especially for the people who are new to PowerShell, this slide kind of pushes it, right? This is getting a little bit weird. If you have some database background or SQL background, then I think it really helps in understanding what's going on. Now, what's going on in the last line? Remember that PS is the alias for getProcess, and I'm using the alias here so I can actually fit it in the slide. Where is the alias for whereObject. Now, the output of getProcess is a stream of objects that represent processes on the machine. Each process object, one at a time, goes into the $_ variable. That's what catches the object. But notice what's going on down here at the bottom. I'm doing 2 tests. Each test is inside parentheses, and between the tests, I have a Boolean or logical operator. So Boolean or logical operators, we have -and, -or, -not, and also exclusive OR, XOR. So here's the idea. I go back to PowerShell on my machine. What if I do something like this? Is 3 less than 4? It is, so it outputs true. But notice, I can put that test inside parentheses. It still outputs true. But then I could have another test. For example, I can do -and then have a second test, like for example, is 4 less than 5? Now we know that's going to output true as well. And true and true outputs true. True and true outputs true, right? According to the Boolean logic tables. Maybe if you did computer science back in high school or college, you talked about exclusive OR, inclusive OR, and not, and so on. In fact, how about exclusive OR? We know that both of the tests here on both sides output true. So this is true, exclusive OR true. What is this going to output? Yeah, false. With exclusive OR, it's one or the other, but not both. Okay, so going back to the slide then. Remember, you have a table in the back of your manual, an appendix, that lists all these different comparison operators. Now for that last line on the slide, if I were to describe this in normal English, it would be something like this. Get all processes where the process ID number is greater or equal to 100, and where the name of that process is like SVC star. In other words, the name begins with the letters SVC followed by anything. Inside the squirrely braces, you have to have a test that outputs either true or false. And the test in this case is the -and in the middle. But we have subtests, so to speak, littler tests inside parentheses. And you can have parentheses inside of parentheses inside of parentheses and so on. So you could have a very precise, but also a very complex filter. For example, you could select all the files on the drive if the file is larger than 1 gig, if the file name extension is .zip, if the last modification date shows that it's been modified in, let's say, the last 12 hours, and where the NTFS permissions on the file deny access to the guests group. And you could actually do it. Now think about how this changes how we view Windows and Active Directory and Exchange Server. We can now view all these things that we manage as, in a sense, like just big collections of tables. And tables are collections of records with fields, or rather, objects with properties. So when you play on the blue team, let's say you're doing threat hunting or auditing, you view your network as this vast, gigantic collection of tables that need to be queried. We're looking for that needle in a haystack. And remember, for all the commands that we're looking at right now, we are running these commands locally by hand on our machine. But tomorrow, we're going to see how to run these commands across thousands of boxes using PowerShell remoting and SSH. So if a comma delimited file or an XML file is like a table on the hard drive, what's the equivalent of a SQL Server table in memory? Well, check out page 104. Arrays are like in-memory database tables. So you don't always have to save the data to the drive. Let's see this in action. On your machine, please go to PowerShell and please run this command. $= get process. Please run that command on your machine. Whenever you see the equal sign, it means run the command to the right of the equal sign and capture the output to the variable on the left. What's inside the x variable? Well, just type in $x by itself and hit enter. And now we can see all the process objects inside that variable come gushing out. Microsoft calls this emitting. We say that the variable emits the objects inside of it. But again, by analogy with SQL Server, $x is like a table in memory. And inside that table, we have records with fields. Here's something else. Every object in that x variable is numbered. And you can extract items by what's called their index number. The way you do it is $variable name, whatever that happens to be, and then a set of square braces, not squirrely brackets, square braces. And inside the square braces, you put the index number. So the first item in the array, the first item in the table, is item number 0. The second item is item number 1. Now this messes up new programmers constantly. Every item in the array, every item in that table is numbered, but we start counting at 0. So the first item is item number 0, the second item is item number 1, and so on. You can also do what's called array slicing. For example, ... tells PowerShell to generate all the numbers in between. So 1.4, as you can see, counts 1 through 4. You can also count backwards, by the way. I could do, like, for example, how about -5.0? So in this case, it counts backwards. Now, how does this help us? Well, you can do array slicing this way. For example, I can do $x 0.3 close square brace. And notice I've extracted the first 4 objects. And why did I extract 4 objects? It says 0.3. Ah, yes, that's right. It's because we start counting at 0. So the first 4 objects in the table or the array is items 0 through 3. The last item in the array is item -1. The next to the last item is item number -2. So you can start at the beginning of the array and count 0, 1, 2, 3, 4, 5, or you can start at the end of the array and count backwards -1, -2, -3. Just be aware that there is no -0. So when you're using arrays, these are like in-memory tables. Arrays have properties, such as the count property. The count property will tell you how many objects are in the array. It might be 0, could be 5, could be 500,000. If you simply type in the name of the array, then everything inside of it is emitted or comes gushing out, and we can pipe those objects into other commands, like the where command. Each item in the array is numbered, and the way that you extract items by their index number is by putting the number inside square brackets. You can also do what's called multiple assignment. For example, from the nums array, we could take item number 3 and put it into the D variable, and item number 7 we could put into the F variable. You could also take an existing array, take a subset using the ... or range operator, and then create a new array, which is a subset of the original array. And as I mentioned, you can count forwards or backwards. So here at the bottom, it says -1 ... -5. That's the last 5 items. If you want to create an array manually, that's done with the @ symbol and the parentheses. @ symbol parentheses tells PowerShell, create an array out of anything you find inside the parentheses. Could be empty, so that's all right. You would just have an empty array. Or you can have an array of one item or many items. Just separate each item by a comma. In all the examples so far, we've been using the equal sign. Now the equal sign will overwrite and replace anything in the variable to the left of the equal sign. So if you already had some data inside the x variable and you overwrite it, that data is gone. Now on the other hand, plus equal, that doesn't mean overwrite, that means append. So you could have an array like a grocery list. And so you append to the end of the list a couple items every day, like milk, eggs, and cheese. You're not overwriting the grocery list every single time, you're just appending to the end of it. Be aware that if you append more than 10,000 objects to an array, PowerShell gets slower and slower. So as a rough rule of thumb, if you're going to manipulate more than 10,000 objects, there's more efficient ways of doing it than using the plus equal sign appending. But if you have like less than 10,000 objects, then it's okay to append. It's not that big of a deal. How could you create an array with so many objects? Well, for example, I've got 0.50,000. And that would create an array of 50,001 numbers. And why is it 50,001? Because again, in this example, we started counting at 0. What is the commandlet to clear all variables in memory? There is no one commandlet for that. However, you have a variable drive. It's like a RAM drive. And if you do a dir of the variable drive, you'll see all your variables in memory. And for example, there's the x variable at the very bottom. Now, if I type in the name of a variable, like for example, just the x variable itself, that outputs one object, an object that represents that variable, and that can be piped into the remove variable commandlet. And that's about the closest that you would have. You could try to pipe in all these variables into remove variable. It won't actually work for all of your variables. But at least for your own variables, you could pipe them into remove. Now it's gone. And notice that if I do a dir listing of any variable named x, it says, hey, I can't find it. It doesn't exist. And that's because I just removed that variable. If you're worried about secrets in memory like passwords, just be aware, removing the variable does not scrub the data from RAM. PowerShell runs on top of the .NET framework. .NET includes what's called a garbage collector. And for variables that are no longer used or which are deallocated, eventually the garbage collector will get around to cleaning up that memory. But in the meantime, that data is still in memory somewhere. It's just a matter of using the right kind of forensics tool to scrape it out of memory. Now, when would we use arrays? Why would we want this? By far, the most common use for arrays is to capture the output of commands. And in fact, we've been doing this throughout today. We've seen many examples of this so far. We have an equal sign. To the right of the equal sign is a command, and the output of that command is being saved to the variable on the left. You can run PowerShell commands like getHistory, traditional text-oriented tools like netstat. You could even run, for example, a Python script from within your PowerShell script. Now there is a little trick here in the middle. Notice that I'm running my Python script again, but in this case I put the command inside parentheses with the @ symbol in front of it. When you run a command this way, we're telling PowerShell, no matter how many or how few objects are outputted by the command, put the output to an array. Even if that array will only have one object, or maybe even nothing inside of it, I want to have an empty array as opposed to a regular variable. So here's how it works in PowerShell. When you run a command and it outputs nothing, or only one object, the output goes into a normal variable called a scalar variable. But if your command outputs 2 or more objects, then the type of the variable that it goes into is an array. But you have to have 2 or more objects, at least by default. Now the exception is, as you can see here in the middle of the slide, I run my Python script, but I execute that command inside parentheses with the @ symbol to the left. And that tells PowerShell, hey, even if that Python script outputs nothing, I still want to have an array for the output, even if that happens to be an empty array. Here's another example of using that trick. I'm using getContent to read a text file on the hard drive. Now, sometimes that file has thousands of lines, other times that file is empty. But whether it's empty or has thousands of lines, I want to guarantee that the output goes into a variable named lines, and what kind of variable is that? It's an array. So I can now treat it like an array. It'll have a count property, for example. getContent, by the way, is a very handy tool. You can do tricks like this. You can do getContent *text *log *ini. And let's imagine that expands or maps to 400 files in the present directory. Well, getContent will read all 400 of those files and create one gigantic array of all the lines from all the files. And by the way, all of those lines are converted to UTF-16 little endian, what Microsoft calls Unicode. Even if the original files are a mixture of ASCII, UTF-8, and UTF-16, it'll all be converted to Unicode UTF-16 by default. Maybe that's good, maybe that's bad. It's just something to be aware of. Now in PowerShell Core, on the other hand, Microsoft changed the default string encoding to UTF-8, just like on Linux. So on Windows PowerShell, PowerShell prefers UTF-16, Unicode, but on PowerShell Core it prefers UTF-8. If you don't know the difference between UTF-8 and UTF-16, that is perfectly fine. When you're first getting started, that's an issue that you won't have to know about for a while at least. And finally, getContent can also read binary files. And if you're doing this in Windows PowerShell, then you have to add the --encoding byte parameter and argument at the end. The difference is this: when you read a binary file, we want to tell PowerShell, don't look for any new lines or carriage returns or tabs or other bytes that indicate text formatting. Instead, if this is a 4,000 byte file, I want an array of 4,000 byte objects. Yes, even a single byte is represented by an object. So a byte object has exactly 8 bits inside of it, and it has properties and methods. So as we can see at the bottom here, I'm getting the contents of worm.exe. Let's say that's a ransomware worm that's been spreading inside the LAN. We're going to read that into an array of bytes, and now I could do things like extract the PE header, or attempt to deobfuscate or decompress the file. So you might wonder, how would I use all this in real life? The examples in the last couple of slides are a little bit contrived, just to get us going. Well, here's a more real-life example. PowerShell can search the event logs on local and remote machines. That's done with a commandlet called getWinEvent. As you can see at the line at the top, I'm searching the application log, and I'm returning the 2,000 most recent events from the application log. All that goes into an array on the left-hand side, the events array. On the very next line, the second one, I'm now extracting from the security log the 2,000 most recent events. But notice, I'm not overriding the array, I'm appending to it. I'm using +=. And then finally, I'm extracting the 2,000 most recent events from the system log, and again, I'm appending it to the events array. So after those first 3 lines, we now have the events array. It's got 6,000 objects inside of it. Each object represents an event log message. Each object has properties like date and time, event ID, the name of the log, the name of the machine, the name of the user, and so on. So let's imagine that you're creating a forensics timeline. You want to sort all of these objects based on the time created property, because you want an array of all these event log messages sorted from oldest to newest. As you can see at the line at the very bottom, we're taking that array, the events array, and we're piping it into sort object, but when you sort, you have to give the name of at least one property, in this case, the time created property. So no matter what log the event log message came from, it doesn't matter anymore. We're going to sort all those things based on date and time, not the name of the log. And those sorted objects, as you can see, the pipe symbol pipes it into select. The only properties I care about here are machine name, time created, log name, and ID. All the other properties that I don't specify have been simply discarded. So again, it's like doing a select query where I select just those 4 fields and no other fields. And as you can see with the pipe symbol, those now much smaller, simpler objects with only those 4 properties are now piped into export CSV, and we save the data to a comma delimited text file. Now we might use some other tool with that file, like grep, or import it into Splunk, or open it up in a spreadsheet, anything that you wish. This is relatively simple data. It's called flat data, so it's perfectly fine to save it to a comma delimited text file. If the data were more complex, with hierarchically nested objects, then you'd be better saving it to an XML file or a JSON file. So this is an example of using arrays that is more realistic. There's one last type of array to know about. This is called a hash table, also known as an associative array. Or if you have Visual Basic experience, you might call this a dictionary object. Now, by analogy, think of an old-fashioned paper phone book. The phone book as in a whole is a hash table, but each item in the phone book is a pairing of 2 things. It's the pairing of a name with a phone number. So let's look at an example here on the left-hand side. I have a hash table. This is a special type of an array. I have a hash table named states. And notice that it's @squirrely brace, not @parenthesis. I know it can be hard to see, but @parenthesis is for a normal array, @squirrely brace is for a hash table. Now, each item in the hash table is a pairing of 2 things. In this case, to the left of the equal sign, that's called the key, and to the right of the equal sign, that's the value associated with that key. So for this example, we can see that CA is associated with California, FL with Florida, and so on. If you separate each of these pairings on a separate line, that syntactically is perfectly fine. You don't need semicolons. But by the way, if you were to put this all onto one long line, you have to put semicolons, not commas, semicolons in between each of the pairings. Now, how would you use this? Well, it's the same way that you'd use an old-fashioned phone book. On the right-hand side, if I just do $states, that outputs a table of all the keys and values. Key on the left, value on the right. But what if I wanted just the value associated with the key named CA? We can treat the key as like a custom property. So I can do $states.ca, and the output of that command would be California. So a very common use for hash tables like this in PowerShell is to create your own custom object with your own properties and your own data inside those properties, because you can treat the key, the item on the left, as the name of the property. So one way to think about it is, what do we have? We have the states hash table. The CA property contains the value California. So technically, we would call CA, we call that the key. But if you want to think of it as a property, that's perfectly fine. Now looking at more examples on the right, if you have an existing hash table, like an existing phone book, then you can call the add method on the hash table, and then it's key, comma, value. Or if you want to remove an item, for example, I want to remove the CO for Colorado. I want to remove the CO key, then that'll remove it from the phone book, or rather from the hash table. You can also extract just the keys by doing .keys, just the values, everything on the right-hand side, and you can do Boolean tests, true or false, does it contain a particular key or contain a particular value? We're going to see lots of examples of hash tables in this course. Tomorrow, for example, we're going to create a hash table of allowed commands in PowerShell, where you can block all commands by default, except for the commands listed in our own hash table. This is an example of using a hash table. And it's got a good funny name, splatting. So here we can see we've got a hash table named paramargs. So we have keys on the left, like computer name, log name, max events, values on the right. But notice that these keys look like the names of parameters. And the values on the right are similar to the arguments to those parameters. And in fact, that's exactly what it's for. If I go back a couple slides, don't worry, I'm going to come back again. Notice that we have a command getWin event. It has a log name parameter and a max events parameter. So going back to the splatting slide then, that's what these things are on the left. The keys in this case are the names of parameters, and the value on the right are the arguments to those parameters. And notice the trick that we're doing at the bottom. This is the splatting technique. GetWin event @ hash table. That is passing in a collection of parameters and arguments in one shot. This is a very common technique in PowerShell. It's called splatting. And this is a way of organizing all of your parameters and arguments into a more manageable data structure called the hash table. And then you can pass in that entire long list of parameters and arguments in one shot. And the hope is this makes the code easier to understand.